If your websites conduct transactions or collect sensitive data, you have a material risk on your hands that could cost millions. The client-side security gap is being exploited daily with attacks like digital skimming, credential harvesting, and form jacking. 98% of sites use first and third-party JavaScript to power and enhance the user experience, opening up the client side to the adversary. Unlike most things in security, there is an easy fix. Start by understanding your risk. Let Source Defense give you a site-wide risk report this week. Visit securityweekly.com/source defense. Welcome back, everyone, to Paul's Security Weekly. If you've got a specific guest or topic you'd like to see on one of our upcoming shows, submit your suggestions for guests at securityweekly.com/guests. Complete that form, and we review those pretty much every week. So make sure you do that. Mr. Lee Neely has joined us. Lee, welcome.
Hey, good to be here. Just too many compliance meetings today. I don't even have a good dad joke today, except this is something I've been looking forward to.
Good to have you, and I love your shirt.
Thank you.
Joining us for this segment is Mr. Saumil Shah, an organizer and founder of Ring Zero Training. Saumil is an internationally recognized speaker and instructor, having regularly presented at conferences like Black Hat, RSA, CanSec West, PACSec, Eurosec West, Hack.lu, Hack in the Box, and more. Saumil, welcome to the show.
Good afternoon, Paul. I'm glad to be here. Thank you for having me.
Saumil, reading your introduction makes me wonder and apologize for not having you on the show sooner. So it's wonderful to finally have you here on the show.
Thank you. It's a pleasure to be here too.
I'm going to be somewhat flattering because I'm like a huge firmware security nerd, and I tend to follow and seek out like anyone and anything that is related to firmware security, reverse engineering, or virtualization. And I stumbled across your work in my research, and I was kind of like internet stalking you, dude. And I was like, who's Saumil? And I'm like digging up all this stuff. I'm like, we have to get Saumil on the show. I'm like, this is so cool. And it was so nice to see your research that you've presented and trained on, and to see that journey of where you are today. So now they got that out of the way, I want to ask you, how did you get your start in information security?
I've been a hacker since 1998. Those were my first steps out of Purdue University. Joined what now became as a penetration testing practice. My first few hacks were, on the usual Sun Solaris systems, binary exploitation. And then along the way, several things happened. Like I started my own company, NetSquare. I started doing web hacking, and then got a little jaded with web hacking. Along the way, I started teaching. I used to teach several conferences. Now I'm like 22 years into cybersecurity teaching. Started teaching binary exploitation, and about 6 years ago, started pivoting into ARM and the world of ARM IoT. So that's what,
Yeah, so like you've been teaching like security basics, like easy stuff.
Yeah, it's the fundamentals, shall we call it that?
Yeah. No, dude, those are like your experience shows some really in-depth knowledge of exploitation and vulnerability research. And then you're like, that's not hard enough. I want to go pivot to the firmware side of things. So,
Yes. Well, there's two things about training, right? First of all, I need to stay out of trouble. So I need to learn new things. If I don't learn new things, I get bored very quickly, and I'm not very happy. Committing to training forces me to learn new things and reach up to a level where I can be confident that I know the subject reasonably well. The other thing I've seen is a lot of people just need a start up the hill. The learning curve's getting trickier and trickier with every year. So what I do in my own exploration, my research before the training, that's essentially what becomes the training, like how I went through it, curate my journey, and present it in a condensed form to my students.
We talked about this, right? Like you read 20 or 30 blog posts or articles or papers
exactly
to like do what you want to do. And you're like, crap, I really want to do this. And then I got to like read all this stuff and like learn it and then do this. And then it still doesn't work. And I have to iterate on my own. And then I figure it out. You've been like gracious enough to go, I'm going to teach other people how to do that. and that's really awesome.
Yeah, it's like 10 hours of searching around results into 10 minutes of productive, efficient output.
Yeah.
And it's not rocket science. I mean, it's not like stuff that I discovered on my own and I want to keep it hidden. It's out there. Why not curate it? The other benefit of teaching is I always learn something new.
Yes.
There's always brilliant students who surprise you. And that's what I really look for in all the classes. So in a way, yes, there is a give and take. I end up learning by teaching.
Yeah, but how did you learn? You were writing exploits in the early days, right? That seems to be your background. How did you learn that?
Yeah.
Was it or your own research, or did you take classes or have teachers, or?
So this is a bit of my unknown past. In the early 90s, I used to, shall we say, dissect MS-DOS viruses. I used to write vaccines for viruses like Dark Avenger and such back in the day. And also use this to hot patch games like Prince of Persia. And that was like my entry to I didn't know I was hacking, but I was hacking and stayed with low level stuff ever since. After university, I got into this because now it became a profession. Like, wow, I can get paid for this. That's brilliant. Let me do that. Let me continue. So it's been a breaker.
Yeah. What turned you on to firmware in security, I guess we should say, right?
So it's like the 90s are calling, right? They want their exploits back. Like we went on a whole journey of maturity of the desktop platform. There's several layers, and every time you have this, Tom and Jerry game, like there's an exploit mitigation technology, and then something comes about to defeat it, and it keeps on going. I started realizing that desktops and server-side security in the Intel world's kind of getting to be saturated. Like there's not much more new great things happening, but there's like an explosion of IoT devices. And first few investigations inside reveal that, okay, all it is a Unix-ish operating system on a different processor. I mean, how hard can it be to learn? It turns out, it's not hard, but it's a very different journey. And the way IoT devices are organized, there's a certain fundamental differences which we don't realize between the desktop platform and the device. We take a few things for granted on the desktop. It turns out it's like vastly different on a device. More importantly, it is the business processes and drivers that are responsible for firmware insecurity in an IoT device. Nobody sees what's going on an IoT device. It's all black box behind the scenes, and there's like an LED light blinking on and off. If you don't see it, you don't know what's in it. If you don't know what's in it, bugs will go unnoticed for years and decades. And it's exactly that. Like the old buffer overflows are coming back again. It's simple, but it's there, and it's now there everywhere.
Saumil,
So
it's funny.
Okay.
I was explaining to the intern, I had a little TP-Link router, and when I plugged it in, a whole bunch of lights would blink in a certain sequence, and then it would stop, and then like the same sequence, right? And I'm like, I'm telling the intern Dylan, I'm like, you know what that means? He's like, no, what are you talking about? He's like, just lights flashing. I'm like, those lights are being controlled by software that's running on those chips, and those lights are indicators, and it's very purposeful what they mean. And I'm like, I kind of guessed, and it told me that it wasn't getting enough power. So I switched to a different power source, and I'm like, look, when it boots up, those two lights stay on. And I'm like, that's all controlled through software. And then I told the story when I wrote the book on WT54G routers with Larry, that Larry and I wrote a script that would blink all of the LED lights on the WRT54G, and we called it the Christmas lights kind of thing. And like, it's all just controlled through software.
You didn't call it Kit the Knight Rider lights?
Yes,
that would have been a great idea.
Right? There's a lot. It's a great point. There's a lot of things you could do with it, but I'm like, all those lights mean something. It's different stages of the boot process and things like that. And it was kind of like, it was encouraging for me to see his realization that that's your monitor, mouse, and keyboard, right? Or at least your monitor on your IoT device. That it's sending you telemetry. There's just no monitor on it, but it's blinking lights.
Right. Exactly. And it's exactly the reason you touched upon, Paul. There is no monitor, so you don't see it. If you take a modern router, like I have a Tenda router, it's manufactured 2018. What's the kernel version that it's running? Linux 2.6.
Ugh.
When was the kernel written? 2002. Why is this kernel still being published in a modern router which is built about a decade and a half later? It's got to do with reference design. It's the tool chain that was supplied by the vendor, has not been updated for decades, and this is the same tool chain that these guys got to use. So, like I tend to say, Linux kernel 2.6 is the IE6 of IoT devices. It's going to be there. It's never going to go away because nobody makes a penny on upgrading the firmware. If it works, it works. There's no business driver in upgrading the firmware.
There's no economic incentive for that manufacturer to go, I want to be in the latest Linux kernel. This kernel works and is probably a whole heck of a lot smaller because you're constrained on size than more modern kernels. So why wouldn't I go with the older one?
Exactly that. And the other thing is the binary blobs that the driver vendors give you. They don't give you the source of the driver. So if the driver is built with kernel 2.6, guess what kernel you have to use? You're forced to go with it, even if you want to use a better one.
That drives me nuts. That's still a thing today. Those binary blobs, right? And there was a lot of people that have reverse engineered them and gotten them to work and extended functionality, but that's still kind of like shooting in the dark, right? Even though you've reverse engineered it, this isn't like simple code. This is a driver for a Wi-Fi chipset or a SoC that there's so much in there.
I mean, you may reverse the driver, and that's great, but you're not going to be able to upgrade it.
Yeah,
you can't rewrite the driver and patch it in. You're stuck with that blob.
Yep. Tyler?
I was just going to say that is a big concern too, because when those get compromised, they get reversed, they get vulnerabilities found within them. There's not a great way to fix them if they're on some of the older versions. They just have to function, and the code that you're using, you have to deal with, and therefore those devices become obsolete. Or they should become obsolete, but they don't often.
Yeah, so you can just go upgrade the kernel, but that now we're going to get really nerdy. One of the things you taught me in your training that you've released open source, right, is that when you're emulating firmware and you want to take a kernel, you can't take the kernel that was running on that embedded device. Like you can pluck the kernel out of the firmware, reverse engineer the firmware blob, pluck the kernel out, but you can't run that kernel because there are kernel drivers within it that are specific to running on that hardware. Since you're emulating the hardware, you need different parameters. So unless you want to go rewrite all the kernel drivers, you have to run a different kernel and do different things. You can explain it better, Saumil, but that was a huge realization for me.
Yeah, you actually, even if you rewrote that, you can't, because the emulation environment provides you a few reference boards, and these reference boards have a certain set of peripherals that are emulated with. Now, if you really want to emulate the whole thing identically, you have to kind of go into QEMU and create your own reference board with the matching hardware. And that is like, you need to be like Fabrice or someone who's, dirtied their hands with QEMU for about 20 years. And that's not happening anytime soon.
Yeah, that's a serious level. I think we're understanding what a serious level of engineering that is, and understanding the hardware and the software to such a level that you can create the emulation of all of the different devices, essentially. I mean, the IoT router looks like one device, but like on the circuit board, there's the Wi-Fi chip, there's the networking hub, there's the RAM, all the devices, maybe not RAM, but all the devices on there.
Right. I mean, absolutely. If you take a look at an IP camera, it's not even different and discrete as we think it is. It's all on the same SoC. And one of the things that ARM did to chalk its success was ARM would give vendors the ability to customize and configure their own hardware. You can mix and match whatever you want, and you can fab your own chip. So if you want to actually implement an IP camera today, your best bet is the Faraday 626 processor, which is specifically built for IP cameras. It has a frame grabber on it. It's got the Wi-Fi subsystem on it. It's got like the MPEG encoders or whatever you need for video streaming. What version of the ARM core is the Faraday 626 running? It is an ARM v5. no data execution prevention, no ASLR. So exploit mitigation, not even built into hardware. We've come a long way since then. But today, if you want to implement a new IP camera and you go like, I'm going to use the latest ARM chip, I'm going to use the latest the frame grabbers, your cost of hardware becomes tremendously high. So you're going to fall back and go back to a chip manufactured in 2007, which is a Faraday 626, and use that simply for economical reasons. And you end up with an IP camera that works very well, is highly vulnerable.
You're explaining how the market gets flooded with these cheap, extremely vulnerable IoT devices.
Yeah.
And
You're
we tend to
essentially
think of those.
competing in.
Sorry, everyone was talking at once. Go ahead, Saumil.
Binary exponential back off like Ethernet. Okay, I'm going to go. Right. So everybody's competing in a sub $50 space.
Right.
You're fighting for every cent. And this is where, shortcuts and corners are being cut. And that's what's at work over here.
Right.
Lee?
I think one of the
Tyler. Sorry.
I was going to say that doesn't seem like a huge deal, right? Like, okay, so we have you get what you pay for as a consumer. Yeah, they're going to buy it because the price point's right, the feature set's right. People don't really think about the implications of that from a broader scope. When you start to think about things like the Mirai bot or some of the trick bots or the denial of service botnets that get built and leveraged in ongoing cyber attacks against critical infrastructure during a war, to distribute malware for things like ransomware, Conti, all of those things, the implications start to become a little bit more clear as to why this is actually a much more prevalent problem that does need to be addressed all the way at the vendor level for even the cheapest of devices that we're putting out there, because they are becoming a problem and it does hurt everyone.
That's right.
Yeah, it's tough to find an analogy, I think, to that, Tyler, about being a good net citizen and not putting vulnerable devices out on the internet like that. Like, this is enabling vulnerable devices to be on the internet and is affecting the essentially, malicious actors in their ability to operate in a positive way and putting the defenders at a disadvantage. Like, what's the analogy to that? Like, I struggle to come up with an analogy to that, but it basically means there's a flooding of the internet of these vulnerable devices that are used in an attack chain that's allowing really bad things to happen.
So,
Lee,
I was as we were talking about the price point a minute ago, I was reminded of the line from the scene from, I think it was called Back to School, where they described a new product, and it's like the CEO was like, "Yeah, and put it on the market for $19.95."
Yes.
And I'm thinking, really, it's about the price point, availability, and working, not about the security. But there's been some effort, and I have not tracked it in a while, to try and create some like IoT standards at the congressional level. Do you think those are going to make a difference in our lifetime?
No.
No.
Now, look, I'm going to back Saumil up. I used to work in video surveillance, and I worked for a company that subbed another company's chips into their cameras, and eventually they were planning on building their own chips for the advanced features. And it was a cluster to try to get anything done that way, to the point that it was actually cheaper to buy higher end chips and destroy some of their functionality so that you could differentiate yourself than it was to actually build your own chips or design your own chip. I mean, it was ridiculous. Just in the video surveillance world, your point about firmware being, I don't know, commoditized, horrible, bad.
Yeah, no, it's a great point, Josh.
But to speak to the point made earlier about any references that might help improve, I don't know about the standard that you were referring to, but I've seen a trend where several router manufacturers are starting to use OpenWRT as their base. I mean, you may still see like a TP-Link interface on top of it, but if you dig into the core kernel and the file system, it ends up being all OpenWRT. Personally, I think that's a great step. It's a step in the right direction. You're creating a more flexible, a more upgradable framework by using something like OpenWRT as a base. I wish somewhere, somehow, there's like a conglomerate that happens and says, okay, you know what? We're committed to contributing back to OpenWRT in order to improve improve scalability and thereby security for all of us. I don't know when such an alliance may get together, but I still have hope for it.
Yeah, I mean, on the other hand, Saumil, I apologize. Let me just throw one thing in there.
Josh.
And that's that, you're right. OpenWRT is a fantastic foundation that you can customize with the UI however you want, make it look all pretty or fancy or simple or utilitarian or whatever. And then you've got a monoculture, which is how Mirai came around.
Yeah.
Yeah, and exactly. Also people can configure it poorly and not update it.
So
that's
it's a trade-off.
Yeah, it's a trade-off.
Not that you're wrong. It's just it's a trade-off.
No, you're not wrong. And also, you have to be able to upgrade that. Like, I've got a MoFi device. It's a 4G router. And I'm like, oh, under the cover. Like, I can even tell from the web interface and just various signals. I'm like, oh, that's OpenWRT. I mean, Nmap it, and that's OpenWRT. But it's an old version, and they haven't updated it. And I'm like, you have such a great opportunity here to do it. And maybe they are, but then it's up to the user to upgrade and get to the latest firmware.
I mean, there's also been talk like, should there be auto update in IoT? And I've seen a lot of thought leaders get it wrong. Say, yeah, why don't you just build an auto updater? Because we're doing it in Windows, we're doing it in Ubuntu, and just, download a new fix. Well, guess what? It's not going to work on an IoT device because flash memory is not the same as spinning disk or SSD. There's only a finite amount of times that you can reflash memory before you brick it, and it becomes like a CD-ROM. Your auto-update strategy, the way it runs with the same frequency on desktops, is not going to cut it for the IoT world. We need a better design or a better layout, for lack of a better word, in order to secure IoT devices. And I would go in the direction of minimalism, like just throw only what's essential, let it out, and remove everything that's not essential on there.
Yeah, like universal plug and play should never be there.
The marketing guys need to check off a box. If they don't have it, it's not going to sell.
Yeah. No, it's interesting. OWASP for a while was maintaining an IoT top 10 list. It looks to be like that project isn't being actively maintained today, but they address, it is a good list in that they address, a lot of the issues that we're talking about, right? Certainly authentication to the device from an administrative perspective is huge. And that's what I like about, back to your point, Saumil, about standardizing on OpenWRT, for example. And if OpenWRT says the authentication mechanism to administer this device is standard and it's secure, right? Like there's no authentication bypass, there's no default usernames and passwords, the user defines all of those. That's a step in the right direction to kind of advocate for your notion of OpenWRT, right?
Let me give you an analogy. What happened with Alpine Linux? I love Alpine Linux, a minimal Linux distro, and it doesn't have systemd, which makes me really happy. We're not going to get into the systemd debate over here. But how does Alpine ensure its longevity? If you're an open source developer, there's only so many years you can give before you say, like, okay, you know what, I'm burning out, I need more money, I need a better job, I need to take care of my family. What happened is Docker took over, they integrated the folks who built Alpine, and Alpine is now the flagship system that comes with Docker. And that's how it ensured the longevity. Alpine stays as its own project, but being, what shall we say, blessed by Docker, it's got funds and wings to run on. Something like this does not need to happen to OpenWRT.
Yeah.
And that's the step ahead I would like to see.
No, I completely agree. Saumil, I want to talk about kind of the history of firmware emulation. So having looked into that in the past, it is likely one of the most difficult technical challenges that I've ever run up against, to be able to take firmware and reverse engineer it and disassemble it is an extremely difficult task. There's some great open source utilities and projects and documentation on it. There's, of course, also commercial companies that have taken it to the nth degree because they have commercial funding, and they're doing a great job. Don't get me wrong.
Right.
I mean, Craig Hefner is one of my heroes in this space, right? And Reform Labs is still running today, and they're doing great work, right? And there's Finite State and a bunch of other companies, and I applaud their efforts and work. But if you're a researcher and you're like, I want to emulate firmware because I want to attack it. I want to emulate it to be able to attack it, to be able to find exploits, to be able to put it inside of a lab that can interoperate maybe with other things and allow people to learn how these things are exploited without having to have a physical device, I think is really cool. And the efforts in that, I think you said it on our prep call, Saumil. You're like, it typically works for the author and in a very like narrow environment. And you step outside that and you're in like a world of hurt and you're doing a lot of engineering to make it work. Is that what you were up against and then finally decided to create what today you call Emacs?
I'd like to backtrack a bit and give you a bit of history about how Emacs originated.
Yeah, please do.
First of all, to address your point, there's always something that I've seen called conferenceware. It works for the conference you've presented at, and then it kind of just decays away. There's been several instances of conferenceware in trying to emulate firmware. My need was something different. When I first started doing ARM IoT training, I needed a good lab environment for myself and for my students. One of the challenges with reversing IoT devices or even debugging them, even if you have an actual hardware, even if I had, say, like 20 IP.
Oh
boy.
You're
going to like.
Sorry, you froze there for a moment. Just for our audience, Saumil is actually at CanSec West, which is we were talking how much we love that conference in Dragos and all that stuff. So yeah.
So okay, let me back up and say what I might have missed. So even if I had, say, 20 IP cameras to give to all my students, how are you going to get a debugger on there? How are you going to get the debugging tools on the IP camera? It's a closed system. I can't like customize the firmware and reflash it with GDB and give copies to students. And then if you want to get some other stuff loaded on there, it's not possible. So at the core of my training, a reliable and a flexible lab environment is key. There was nothing. There was no VMware for IoT.
Right.
So I said, okay, first time, how hard can it be? Let's just pop this firmware into QEMU and boot it up.
Well, hold on.
Why was I in for a surprise?
I want to talk about another, I think, driver for me is there are so many IoT devices on the market, and I want to play with all of them and evaluate the security. But like I physically can't go get all these devices and power them and have them in a lab. But if I can virtualize their firmware, I can have one computer that runs all of these IoT devices all at the same time, which for a security researcher is a hugely valuable thing.
It's a hugely valuable thing, exactly. So there were two goals that I had. One is to, of course, create the lab, scale it, different models, keep adding different devices from time to time. The other was accuracy in emulation. Like since I teach exploit development or teach fuzzing, I need to be able to have the exploit run without any modification on the real hardware if it succeeds in the emulated environment. So that required a lot of diving deep into how the device actually works and making sure that every step of the way the emulation is accurate and faithful. I need all the addresses, all the offsets, even stuff like cache incoherency has to be accurately emulated in order to get production level exploitation going on. So I started this journey about 5 years ago with a bunch of shell scripts wrapping around QEMU. Eventually, I released the first iteration of my framework. It was called ARMX at the time because it was only emulating ARM devices. I released it at Hack in the Box Cyber Week in 2019. The pandemic years allowed me to Dockerize the whole thing and also add MIPS support. With MIPS being added, I could not call it ARMX anymore. So I chose Emacs with the help of a couple of my friends. And that's what I actually just presented at CanSec West few hours earlier, the latest version of Emacs.
Hopefully with great reception, because I'm a huge fan of the project.
Yeah.
Thank you.
Yeah. But what I thought was also amazing too, getting back to the kernel, if you've ever cross-compiled everything, so if you're on a x86 based computer, which most of us are, you have to compile code for a different processor architecture, which is, for those listening, right, that's where we get cross-compiled. If you're just cross-compiling a binary, let's say, that can be, it's a huge pain in the ass. I mean, like, I'm not going to mince words. Saumil's shaking his head, right? We can agree it's a huge pain in the ass. When I was looking at your research, you were like, you need to cross-compile a kernel. Because, like we established, you can't just use the kernel that comes with the firmware. You got to create your own kernel. When you don't create your own kernel, you compile your own kernel. But you're not compiling a kernel for x86. You're compiling a kernel for ARM or MIPS. And you could get a Raspberry Pi and compile an ARM, but that's only... So also, I should back up, side note, ARM and MIPS all have different versions of the different processor architectures. I mean, roughly like a dozen in each kind of camp, right? Maybe more. So now you've got to cross-compile a kernel for different processor architecture on an x86 architecture. Compiling a kernel is a pain in the ass on the same architecture, let alone cross-compiling a kernel. So, like, when I was reading through this, you and others, a few others actually, have kernels that are available that you've done that work for us. And I'm like, I want to get to the point where I can cross-compile my own kernel, and that's like the nerdiest thing. Like, I feel like there should be a T-shirt or an award. Like, I've cross-compiled my own Linux
I cross-compiled my own kernel.
Right?
Exactly. You don't have to look much further than my repository, Paul. A couple of months ago, I published the build root toolchains that I've used for cross-compiling all my ARM.
Build root is it's like the set of utilities that allow you to cross-compile software. Yeah.
Yes, but there's 80,000 versions of build root too. So choosing the right build root took me about 6 months of tinkering and largely trial and error.
Wow.
It was like an Edison feeling once you got one version of build root built for ARM, the same one for MIPS and MIPS Big Endian. Once it all worked, I published them onto GitHub, so anybody can use these well-oiled tool chains to cross-compile their own kernels. My students, I also give them a Docker image that has all the cross-compilers on it. So it makes the whole journey of setting up the tool chains. It takes the pain away from setting up the tool chains.
It's just it's an amazing feat of engineering. Like, for those listening that haven't like gone down these paths, like, you need to have an appreciation for what Saumil just said. It's a lot of work.
It's a lot of work, and you need to sift through thousands of options before you get like the first pass done.
It's amazing.
So,
Lee.
I was going to say, I'm having flashbacks to like 1991, 92 when I was playing with cross-compiling. Because we didn't have it. We had a custom system. It had a MIPS CPU, and our interactive computers were Sun Sparks, excuse me.
Yeah.
And it was. I'm like, bravo on you for getting that done in only 6 months. I mean, it totally blows to do that. I mean, it's really cool when it works, but it's a really hard journey.
It's a long journey to get there, right?
Yeah,
Then also, Saumil, I think something I want to make sure our audience knows too is that, because I've been down this road, back to, I'm a security researcher, and I want to go see if there's vulnerabilities in this particular firmware of this device that maybe isn't manufactured anymore, but there's a firmware image out there for it. And it's hard for me to get this device, and I can only like buy so many of these devices, right? But I got the firmware, and I want to emulate that firmware. Now, you've got a set of firmwares that are emulated in your Emacs project. And you said, what was the length of time, like even using Emacs, and we've established that you've got precompiled kernels and an image where you can get your own build root, so you can compile your own kernels. You've done some of the work for us. But if I've got a new router, or like new to me, maybe it's an old router, I've got a new firmware that you haven't emulated, how much time does it take to reverse engineer that firmware and then do all the right parameters to be able to emulate that firmware? I think you said it was like 6 weeks, 8 weeks, something like that.
3 weeks would be a good median. Sometimes you get lucky and sometimes you don't. So be prepared to invest about 3 weeks when you're dealing with a new device that you want to emulate. You're going to get up to 90% very, very quickly within like 2 or 3 days. And the last 10% is going to vex you for a very, very long time. until you finally have that eureka moment and everything works.
It's amazing. We can take operating systems, right, in a lot of virtualization environments and go, look, I'm running this flavor of Linux and this flavor and this flavor. When you distill it down to these firmware-based operating systems, it's not like that. It's not like I can just take a firmware image off the shelf and go, oh, in a couple hours, like I got it running. Like there's
no. It's and the reason is every device has differences in implementation of the startup scripts.
Yeah.
Some have monolithic binaries, some have third-party web servers plugged in, some have like PHP or stripped down PHP stuff. Some have shell scripts. You got to just cruise through the file system and inhale the file system for hours to be able to figure out where the starting point is, what the dependencies are, and then look where you're going to get a few processes running, then it's going to stop.
Yeah.
You're going to then figure out, okay, what's stopping, then tape it, duct tape it, push it further.
It's a great point, Saumil. I feel like there's 3 different stages, right? I got to emulate the bootloader to get to the point where I can load the kernel. I got to have a kernel that actually works, which step 2. And step 3 is, once that kernel's loaded, I got to load user land and run those binaries, because your typical IoT router, for example, let's say I want to pick apart the web application and find like the great flaw, right? Authentication bypass in the web interface, and I don't have the physical device. I have to emulate the boot process, the kernel, steps 1 and 2. Step 3, the web server and the admin console.
Yeah, exactly.
And that's hard.
I had three questions for you. I mean, it seems like you've got kind of a process and you could teach somebody else how to do it. My questions for you is, you got anybody else interested in going through the same journey you are? And what keeps you coming back for more? Because it seems like you keep repeating. You must be enjoying this.
I do enjoy this.
Glutton for punishment.
Yep.
I'm not judging.
Or thirst for knowledge, depends on which side of the coin you want to look at, right? So one thing is, there's still several areas of emulation that I really want to accomplish. My current quest is for emulating Nvram. My next quest is to probably go down the customized hardware board where I'm reaching the QEMU limits, and I still want more.
Sorry, Saumil, for our audience, describe what Nvram is and the challenges in emulation.
Okay, so let's say you buy a router from the shop. It comes with its own default password, which is either blank or not very good. It comes with a default IP address, and it's got a Wi-Fi SSID, which everybody knows. Back in the days, Paul, when you were doing your research, it used to be called Linksys. Today, you go plug it into your home. You want to configure it. You want to customize it. You want to set a new password. You want to set a new SSID. Where is the configuration going to be stored? Now, IoT devices do not have spinning disks or persistent read-write memory as we are all used to on our daily computers.
Typically, it's a read-only file system as part of that firmware.
It is a read and erase file system. The closest analogy I can give you is a recordable CD. You used to be able to re-record on a CD-ROM, but by re-recording, you're basically just invalidating the previous tracks and you're adding new tracks to it. Right. Once all the tracks are done, you cannot write to the CD-ROM anymore. It becomes a read-only medium. The same holds true for
read-only, and in the case of IoT devices, also compressed, typically squash.
Also compressed. Yeah. Exactly. So you have a separate area on the flash memory, which is called Nvram, which you can read and write to several number of times before it breaks, more number of times than the usual flash. And that's where all the configuration gets stored. It's stored essentially as a key value pair, like an ini file. And the reason, what you said earlier, Paul, is when the device is booting up and it shows all these blinking lights in different stages. That is when the init scripts are reading the configs from the Nvram and building up like etc network config, etc HTTPD config in the RAM disk. Like essentially your file system is being reconfigured every time you boot the IoT device in RAM. That's why it takes a long time to boot as well. So I have got a reasonably decent version of Nvram being emulated. I still want to get closer to the real thing. So to address the question, like, why do I keep coming back? Like this, the more I emulate, the more I learn that lies ahead, and I want it all. I also got interested in different architectures. That's why I added MIPS to it, and expand the world of devices. Like if you want to take a look, I can try and show you what I've got going currently with Emacs.
That'd be great. Yeah, so another aha moment for intern Dylan while you transition there was I was like, when you push that reset button, because the router I had, one of the other things that had happened to this router was it reset to defaults. And I'm like, it knows how to boot into this default mode because basically it's reading the default settings from Nvram, which is the persistent storage, and setting those in the RAM disk. And it's that button that tells the firmware, hey, don't read what has been newly configured, read what's default in Nvram and make those the default settings, and that's how you reset your router.
Exactly. You hit the nail on the head there. So here's Emacs running in a Docker container, and here are all the devices that I've got emulated.
That's a lot more than what you had on GitHub when I last looked, Saumil.
Yes, so these are some of my private stash as well, which I use for training. And I keep on adding more. Like I want this list to grow. Some are contributed by students. Some are like devices I bought off eBay. Like I don't have half of these devices in my possession, but I have an emulated version that I can exploit.
So
this is what makes it really great. So
this is cool.
Wanted to make it easy to select. Like, hey, let's boot up an IP camera. Boom, here it goes. It's booting up, and in just a few, we should be able to have a virtualized IP camera running. Here's the kernel booting on the left-hand side, as you see. And to address your point, Paul, about the user space, this is what's going to take up about 2 weeks of your time to get the user space side of the processes figured out. But once you have got it done, it's in Emacs, it's easy to do it again and again and again. So at this point, any moment now, we should see starting, and the IP camera has started. If I enumerate the processes in here.
Is this much easier to do on like consumer grade IoT devices, or can this be accomplished in a similar manner for, say, enterprise grade stuff if you're able to obtain the hardware?
I don't see any difference between the two.
Yeah, they're very similar.
You were talking about the web interface. So now if I just go to the web server port, there you go.
And that's camera. Like, it's such an awesome moment, right? When you're not in possession of the physical device and you fire up a web browser like Saumil is showing you now, and you can interact with it as if you have the physical device. It's so cool.
Yeah, you can web hack away, you can debug away. It's a working IoT device. It's just virtual.
This is awesome. Can you pull back the list?
Oh, sure. Happy to do that. Give me a moment.
It's only years of Saumil's life he spent curating that list, so it actually.
Well, I'm really curious. Right? Like, I mean, how many? I want to see that expand to PLCs, to cars. I'd love to see an Oldsmobile in there, or whatever.
I think the stipulation, Saumil, is a couple things. One, it has to be based on Linux, right? Currently,
yes.
And it has to be either an ARM platform or a MIPS platform.
Yes. So currently, that is the restriction: Linux on ARM or Linux on MIPS.
Right.
Adding new architectures is easy, but going past Linux into bare metal firmware is still something. It's not going to be easy to do with Emacs. Emacs is highly Linux specific.
Right.
Okay, but if it's Linux based,
Linux with ARM and MIPS, Josh, are that's a huge percentage of IoT devices.
Oh, exactly, and plus there's a lot of other IoT devices that are Linux but may not be ARM or MIPS.
Correct.
So I mean, there's the ability to. Okay. I thought it was 0. I mean, that's just cool.
Awesome.
But we should also Sorry, Saumil, go ahead.
Sorry. I said if you want to add a new architecture, all you got to do is just drop in a new QEMU. Like tomorrow, you can drop in a QEMU system PPC for PowerPC.
Oh,
there's no difference. There's no difference between, like, for Emacs, it doesn't matter if it's ARM or MIPS. All you got to do is tell Emacs, hey, pull up the ARM emulator QEMU or pull up the MIPS emulator QEMU, and it goes to town on it.
Or pull up whatever emulator is available or you can build.
Exactly.
And it'll. Yeah, as long as it's Linux based, because that makes, but Linux is really the only mandatory prerequisite right now. Other than that, it is. Dude, this is so cool. Okay, now
another cool thing, Josh, is you mentioned B-Sides Las Vegas. I gave a presentation with someone that used to work here, Nick Carn, actually, who did great work. And I was like, we should really create a vulnerable on purpose version of OpenWRT. And we did that. We presented on it. We tried to get the community to rally behind it. I think we're just too early, and we, to our, kind of own credit or dismay, it wasn't like fully baked, right? We had some vulnerabilities in there, but not all of them. Since then, what has been very encouraging to me is that others have tried and succeeded in doing that. Now, some projects have been posted and kind of abandoned, but I don't discredit them at all. I love the fact that they tried, they published their work, and it's out there. But Saumil, today, there are at least 2 or maybe 3 distributions that are basically, like we say, damn vulnerable web app. There's damn vulnerable ARM and damn vulnerable MIPS, which are OpenWRT distributions that are vulnerable on purpose, correct?
Yes. So the first 3 you see over here, damn vulnerable ARM and 2 damn vulnerable MIPS. Those are broken router images on purpose. The 4th one down the list is a CTF challenge I created for Excel's phone conference. Like, she runs this event in France, and it's all about IoT and mobile hacking. So I contributed like a broken SCADA controller, and that's the 4th one. And it's if someone wants to play with exploit development skills, I highly recommend these 4. Well tested.
And now, Saumil, did you develop any of those damn vulnerable distributions, or was that someone else?
All 4 are developed by me.
Okay. There have been other attempts, though, right? Other people have published some research on them, but yours work amazingly well within your Emacs framework, which is great.
Thank you.
This is really cool, man. I am really impressed.
I tell you what, Josh, going through the journey that, when Larry and I started looking at this particular aspect of firmware insecurity in 2006, and then fast forward to today to see Saumil's work, is like, it's so exciting. It's so exciting to see work being done.
Can I throw something at you, Saumil?
Please do.
You have this set up so that you can instantiate one or another, test, play with, attack, work on, right?
Right.
Build it so that you can instantiate all of them and run it like VirusTotal for IoT.
Can do. It's a Docker container. Spin up 20.
So I can send the same input. I mean, look, Tyler, tell me if I'm hallucinating here, but if you could send the same attack against all 15 possible devices that could be at a target and see which ones it works on, that would be useful, wouldn't it, Tyler?
Very similar to like a log4j scenario where you need to know.
Exactly. Yeah. So you could send the log4j attack against all of them at the same time. So you don't have to do it for each one. You go, okay, just shotgun at all of them. Here are the 10 devices, 15 devices, 5 devices, whatever, that I think are at my target site. Let me see what percentage of them respond to this attack. It formatted this way. And then you can fiddle with it with your attack and send it over and over and over again until you get the highest percentage. Does that, Tyler, am I saying this wrong?
Or better, take that one step further and say, hey, here's all the devices I have at my edge. Here's all the configurations. I don't want to run this on prod, but I need to know of this list of devices what this attack for the POC that was released actually works on.
Yeah, Saumil, so Tyler and I need percentages, just to be clear.
On a previous technical segment, and this is some of what led me to Saumil's research, on a previous technical segment, I did a couple of them, but the latest one I had a Docker environment, Docker containers, and there were Linux vulnerable systems, some web applications, x86 based Docker containers with vulnerable web applications, vulnerable bash, things like that. There was a Kali Linux distribution. There was just a basic HTTP server that I could serve files to anything in the environment. And then I won't take full credit for this in any capacity. There was research that I kind of called into my own and brought it into the lab that I could emulate Windows running on Linux inside Docker, inside QEMU, and run Windows on it. So I could, in one command, in Docker Compose, spin up a bunch of vulnerable Linux, some attack and command and control servers, and Windows in the same environment. What led me to your research was I wanted to add IoT devices into that. And I think that's just very similar to what you're talking about, is to have a local lab that someone could spin up that has your attack and command and control servers, some Linux vulnerable targets, and some Windows vulnerable targets, and some IoT vulnerable targets. I mean, that is just like the ultimate playground for us to learn and
go
attack.
A step further. You can have 20 instances of Emacs, each emulating a different device, and have GDB attached to all of them.
Mm-hmm.
So you can instantly look, even if there's a crash, you get some crash dump in GDB. You'll be alerted. You don't even need a shell. You get it right there.
I think that's really cool.
You know what you're missing? You're missing the ever-loving NAS devices at the perimeter that are forever getting attacked.
Well,
yeah, I mean, mostly that's Linux-based firmware, Lee, that you could emulate in Emacs. Sure.
I was going to say the next step is collection and honeypots on your edge for each of these devices to see what the latest attacks are getting hit with.
We're going to need to clone you, buddy.
Yeah, I mean, because people like the deception companies have used similar things, but they just barely emulate the IoTs. You're really doing it in full form, and you're doing it more simply, like with the Docker containers. It's just boom, 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 done. This is Lee just mentioned in messaging. This is slicker than snot, and I will have to agree with him. We all need to chat with you at some point because this is really cool.
Now, Saumil, you are also an entrepreneur in that you created Ring. You created your own training company. Tell us about that.
Yeah. So Ring Zero Training was born out of just going back to the good old days of training. Like, we used to enjoy deep knowledge training. We used to enjoy like a smaller group, really sharp, focused environment. And my personal belief is learning happens inside the class, and the equal amount of learning happens outside the class. You have to have everything right.
I agree.
Now, as various training events grew, things, it became quantity over quality, and I was not too happy with that. So, I walking out of the Mandalay Bay in 2018, I thought, like, okay, you know what? I'm going to do it my way. A few other instructors joined me. I got a few other colleagues, so co-founded Ring Zero and started it. We ran the first event in 2019 at the Excalibur, and then the world got put on pause for 2 years. But we reinvented virtual training. Like, we actually thought of doing training differently to span as many time zones as we could. Stretched what we would do in 4 days, we would stretch it over a week. Shorter lectures, flexible office hours, exercise times. We had collaboration environments, and that really helped solidify Ring Zero. This year we're going to go back to Vegas, and that's the name of the event happening in August in Las Vegas. We're going to have 4 days of in-person training, and the following week, the week after DEF CON, we're going to have a week of virtual training happening as well. So that's what, my personal commitment to Ring Zero is bring in a very good training vibe. As an instructor, know what it takes to deliver good training to students, what the students expect, what kind of environment they expect. You should have like really good food and beverages. You should have a good ambience. You should have like collaboration. There should be no barriers between speakers and students. You should all be able to socialize and hang out. And even like my dream is to have like an instructors teach other instructors session, because we all need to learn. So
you've got an amazing lineup of training classes that you're running August 6th through the 9th, right? This year,
that's right,
in Las Vegas, and virtually as well. I saw one of the names I recognized was Stefan Esser. Is one of your I mean, we all recognize Stefan's name from PHP vulnerability research, right? And you've just got an amazing lineup of training. I was checking it out today or yesterday. I was messaging Tyler. I'm like, dude, we got to go to this training. Like, this training is awesome.
Yeah. I mean, Esser's a legend for iOS kernel and user space exploitation. Yeah, it's great to have him with us.
And your other
again.
other training classes are Active Directory, Mac OS. Like, there's a lot of really in-depth. These are advanced training classes, right?
So what our philosophy is, we want to pick one topic and go, from zero to deep in it as far as we can, given the time duration. And most of our students really want to just get up the learning curve. I mean, these are students who have worked in the field for a while. They need to get into a new area. They just don't have the 300 hours to read different blog posts. But they want to go on a good
I feel that
journey.
more.
Exactly.
I feel that so hard, man. Like, when I need to do a technical segment, right, for the show and cover a piece of research that's like highly specific, you're right. It's like hundreds of hours of reading research papers, watching presentations from previous Black Hat and DEF CONs, going to GitHub and trying all the different projects and getting to that point. Like, not everything is cookie cutter. Like, some of the stuff takes those hundreds of hours that you're talking about. And if you can take a 2 or 4 day training that gets you even 90% of the way there, right? Like, that's a huge jump. And I think that's the value, of your training.
Sorry, there's some internet glitches. Yeah, absolutely. You're right. It's exactly to address the point that you spoke about.
Yeah,
it's awesome. It's great stuff.
I want to use the cliche. You're going to need a bigger boat. You're going to need a bigger classroom. I think you're having a lot of fun, and it shows.
Yeah.
Yeah, and Saumil, this interview was awesome, to say the least. And I've heard nothing but good things about yourself and Ring Zero training. It's got a resounding endorsement from a lot of other people I've talked to, in our field. So I encourage our audience to do this training because I think it's really cool. We just have 5 questions left for you. Ready to play 5 questions with Security Weekly, Saumil?
Let's go.
3 words to describe yourself.
Explorer, artist, teacher.
If you were a serial killer, what would be your weapon of choice?
A knife made out of ice.
If you wrote a book about yourself, what would the title be?
Random Walker.
What is your favorite hacker movie?
Who Am I? It's a German movie. Brilliant.
I got to watch that. I've heard that there is a German hacker. What's the title of it again?
Who Am I? Fabulous movie.
Yeah, I got to find that. Some people have told me that there's a German hacker movie. That's got to be the one. I don't know if there was multiple German hacker movies, but
this one is
good.
Absolutely on target. Yep.
Saumil, choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
2 dads, MC Escher and Martin Gardner.
And who?
Oh,
who are they for me in the audience that don't know who these people are?
MC Escher is a god that I worship, legendary Dutch artist who painted some of the most brilliant illusions and geometry I've ever seen. And Martin Gardner used to write for Scientific American, and he is the reason why I started loving mathematics, after high school.
So
an absolute
Paul,
inspiration.
MC Escher designed the Alien in the Aliens movies. And Martin Gardner was amazing at bringing math to people that didn't understand why it was beautiful.
That's awesome. Awesome. Saumil, thank you so much for appearing on Paul's Security Weekly.
Thank you, Paul. Thank you, folks. It's a pleasure.
Make sure you check out Ring Zero training. With that, we'll take a short break, come back with the security news.
Thank you.